All right, guys, here is the full electron configuration mix. So for this one, this is all part of goal 3. I can recognize and write and recognize electron configuration. So we're mainly focusing for this POGL. This one is focusing on complete full electron configuration, but you need to be able to do this before you can get onto the shorthand or identify stuff. So this is the first part. So here we go. All right, so electron configurations are how electrons are arranged around the nucleus of an atom. So remember, they are arranged in energy levels, which we also call shells. We label these N. Okay, so N in this case is the same as the row on the periodic table. So the first row on the periodic table has got a 1 next to it. That is row 1. So N is equal to 1. Row 2, N is equal to 2. All right, so row 2 has 2 shells, row 3 has 3 shells. We'll get into that as you'll see as we go through that. So each energy level has subdomains. So row 1 only has the S subshell. Row 2 has an S and a P. Row 3 has an S and a P and a D. Row 4 has an S and a P and a D and an F. You notice this only goes up to 4, and there's 7 rows on the periodic table. Right now, the way the electrons are going, we don't actually have anything that goes up past the F orbitals. So there might be something more going up that is going to be discovered later by science, but right now we're only going through F. Okay, here's a way to vision it, okay? So we refer to, N is also the primary energy level. So the first shell in the nucleus, or in an atom, has this is the first energy level, and it has 1 subshell. We know that this is 1s. The second energy level, you see here, is kind of big out here, but that actually has 2 subshells. So this is going to be 2s and 2p. Okay. The third energy level, the third primary energy level, has 3. So this is going to be 3s, 3p, and 3d. We're going to get into d later. D is weird on how you notice that these are all kind of close together, 3 and 4. That's going to come into play later on in a different show, or a different mix. So then the fourth energy level has 4s, 4p, 4d, and 4f. F is even weirder than D. So both of these, though, that's a different mix. So this one's going to mainly focus on the general rules for this and how we fill most of these. We're not going to do much with D and F yet, though. Okay, another way to look at it. So here's the primary energy levels. Don't worry about the K, L, M, N, O. Scientists label everything. So 1, 2, 3, 4, 5. Those are the primary energy level. That's the total number of electrons that can be held in each energy level. But this is basic. This is complex. This is more of what it actually looks like, where you have one subshell, 2 subshells, 3 subshells, 4 subshells. Okay, and so you notice these numbers, the 2, 6, 10. This is key because S can hold 2 electrons, P can hold 6 electrons, D, which we'll get into, can hold 10, and F can go up to 14. These numbers you're going to need to know. Again, this one we're going to mainly focus on S and P, but be aware there is more to come. Okay, just real quick, what is an orbital? An orbital refers to the area in space where there's a high probability of finding an electron. And then the S, P, D, and F refer to different shapes. I like to explain the high probability is you are supposed to be during a certain class period in a classroom. So there's a high probability that someone walking into that room is going to find you there. Does that guarantee they can find you exactly where you are? No, but they know that you should be somewhere in that room. Maybe you've gone to the restroom though. So you're not in the room, but the probability at any given time during your first period class that you're going to be in your first period room is high. That's what we mean by high probability. So the electrons should be in this area, but they could be any particular place in that area. Okay, and then they all have different shapes. The shapes are cool. People like to make models of them. For high school chemistry, you don't need to worry about the shape. You just need to remember S, P, D, and F, and then 2, 6, 10, and 14. Hey, I seem to be repeating this. Maybe it's important. Just so you know, here's the S, P, and then D, there's actually 5. So these gets funky fresh. Just know that it's there, know that it happens. You don't need to worry about it beyond the fact that you need to know that S can hold 2. So each one of these can hold 2, that's why these equal 6. Each one of these can hold 2, that's why this equals 10. Okay, so, all right. So standard notation. This is how we write it. You should have seen this in the POGL. So the energy level, 1, 2, 1, 2, 2, this is referring to the row on the periodic table. So this is talking about row 1. These are the primary energy levels 1 and 2. Okay, so 1 only has one subshell. The letters in blue represent the subshell. So we have 1s, which means the first energy level, and the s subshell. Second energy level, s subshell. Second energy level, p subshell. And the numbers here in red, these are the number of electrons that are in there. This is for fluorine. Fluorine has 9 electrons, and you can see that because 2 plus 2 plus 5 equals 9. Fluorine's got 9 electrons. This is the code for how we write out where those 9 electrons are. So once again, we have this cool little thing. So here's N over here on the side, row 1, row 2, row 3, row 4. Okay, we're actually going to talk about the fact that the periodic table is organized in a really cool way. This first part up here, this is the S subshell. So everybody in here ends on S, and helium is technically part of this, just trust me on that. So like this is going to be 1s1, this is going to be 2s1, 2s2, 3s1, 3s2. So if you're talking about lithium, lithium ends in 2s2, I'm sorry, 2s1. So that means when you write out the code, this is where it stops. Okay. So we have the s orbital. So everybody here is s. Hey, how many electrons can s hold? S can hold 2 electrons. Hey, look, how many columns are there? 2 columns. It's amazing. Next, you have the p orbital. Okay, that's not counting helium. Okay, so these 6 right here, this is the p orbital. Everything in here ends in p. So this would be 2p1. This is going to be 2p2, 2p3, all the way up to 2p6. Hey, wait. There's 6 spaces. How many things can P hold? It can hold 6. Okay. And then we have the D block. Like I said, D gets weird, but we go, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, how many electrons can D hold? It can hold 10. So everybody in the D block, their last place where they have electrons is in the D subshell for whatever row they're in. And finally, they have the F block. The F block can hold up to 14. Okay, these things are still weird. There's going to be a whole separate POGL about D and F. So for right now, you see, this is where they are. Everybody here ends in F, in the F block. But they're a little bit funky. We'll talk about them. But we're mainly going to focus for this one on S and P. So now let's actually get into making these, all right? The secret is to count the number of elements in each row, and that's how many electrons go in a subshell. So here's an example. Here is the first elements 5 through 10 on the periodic table: boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, please note they are part of the P block. Hey, and how many electrons are there? There's 6 elements. 1, 2, 3, 4, 5, 6. That tells us that the P block can hold up to 6 electrons. So if you can't remember that S is equal to 2, P is equal to 6, D can hold 10, and F can hold 14, you just have to go look. You just have to remember where these blocks are on the table and count how many elements are in there. That gets useful. So let's practice this. So we're going to write the full electron configuration for the following elements. We're going to start with silicon. So where's silicon? Silicon is located right here on the periodic table. So that's in row 1, 2, 3. Okay, and that's also, so we have the S block here, and we have the P block here. So it's in the P block, and it's 2 spaces over in the P block, and it's in the 3rd row. So that means silicon ends on 3p2. So when we write the configuration, that's how we know where we're going to stop at. So then we just start writing. So we have the first block. We have the first block. So we have 1s, and we know this is full because we're going to P. So we put 1s2. Okay, now we have the second block. 2, we're in row 2. We We have the S block. We know the S block's full because we got to keep going, so it's 2s2. And we keep going. Now we're in the P block. Okay, still in the second row, so 2p. And we know we have to go all the way to the end of that row. So 2p6. Come back to the next row. We're in the 3. So now we're in the 3 and the S block. We know we're going to use both of those because we're going all the way across. So 3s2. And then we go over, and now we're at P. Still in the row 3. So P3, sorry. P block, and it's 2 elements in, so 3p2. There's silicon. Okay? So now if we wanted to go to calcium, we have to remember where calcium is. Calcium is located right here. That's actually in the 4th row, but it's still in the S block. So we know it's going to be just like silicon, except it's going to keep going. It's not going to stop at 3p2. So we start. We start at the top, 1s2. Keep going. Now we're at 2s2. Keep going. 2p6. We're still going. We haven't gotten to calcium yet, so we keep going. We end up at 3s2. Okay, we keep going. Now, before we stopped at silicon at P2, but we actually keep going through this one, so we go all the way through. So we're still in row 3, and row 3, and the P block, and we went all the way through, so there's 6 electrons in that. All right, now we're on to the next row. So we're 4, and it is the S block, and it's the second one in the S block, so it's going to be 4s2. So there's our practice writing this. So remember, you got to remember what the block is, S and P, and you got to remember what the row number is. All right?